not going to run through all of this because it is brief, but reminder that what we're really trying to do is talk about refactoring code and design patterns and think about adapting our application. So module 9 or chapter 9 is all about method level refactoring individual smaller pieces of code. When we're talking about solid and design patterns, we're really thinking at a higher level of how the classes in our app interact with each other, and perhaps at an even higher level, how our application interacts with different services. So this chart's in a couple places in the book, but compares how we should approach refactoring methods versus refactoring the design of our application. The S, single responsibility principle. Each class should have exactly one responsibility or reason to change. In that, we should keep our classes small and coherent. We can use things like the lack of cohesion of methods as an exact metric, perhaps, to indicate that our class violates SRP. And of course, we can do things like extract subclasses, extract methods to delegate or to compose classes. We have the open and close principle that a class shouldn't require adapting its class to extend the functionality, or that we should have specific points in which we extend the functionality, such as different kinds of reports. Most common symptom to be aware of is case statements that will constantly require adapting. And to address some of these issues, various patterns like the abstract factory pattern, the template and strategy patterns, or decorators can help address open and close principle. Liskov substitution principle. A subclass of type T can be safely substituted anywhere that T would be used, which is to say subclasses should always refine the behavior of their parent classes. The symptoms that show up for this, the refuse bequest, which is no meaningful way to implement a behavior on a particular subclass. So if you're subclassing something and you find that you can't implement the behavior of a parent class, then that's a hint that this thing is not, in fact, a subclass. Again, composition over inheritance is typically a way to resolve this issue. Dependency injection. When we work with collaborating classes that may vary their needs at runtime, we should inject a dependency between two classes. Symptoms of this typically include things like if we have a mock train wreck where inside our test cases, we need to constantly mock out an increasingly complicated series of objects, it suggests that two classes could have a dependency injected between them. Unit tests that require too much stubbing, perhaps, and various patterns like the adapter, facade, and proxy patterns can help inject a dependency between classes that alleviate some of these issues. And finally, in solid, the law of Demeter. Talk to friends and not talk to strangers, which is to say that we should avoid long chains of method calls. So delegation, the visitor patterns, and the observer patterns can help alleviate this issue as well.